6 continents separated by vast expanses of water. This is the familiar image of our planet that we have all shared since childhood. But the Earth has not always looked like this over the history. The Earth has changed so many times and transformed heavily from when it first formed. Millions of years ago, Earth looked very different. All the continents were fused into one. The emergence of supercontinent that united almost all of the land masses about 335 million years ago. There was only one supercontinent consisting of a large part of the Earth's surface. This continent was called Pangea. Pangea then looked like a mystical world, where the Earth seemed to have existed forever and where animals and plants live in places. So let me take you on an epic journey back in time of the last supercontinent, Pangea. In this time, some of the most incredible species that roamed our young planet are about to emerge and explore the unique and mysterious world. When you think of prehistoric times, you might picture of dinosaurs rampaging through the jungle with its razor-sharp teeth. But even before the dinosaurs, there were other giant creatures ruling the Earth. Yeah, welcome to the Carboniferous period. Have you ever come face to face with a dragonfly the size of an eagle? If you would walk the surface of the Earth during the Carboniferous period, it might have happened. Certainly, the Carboniferous period was home to some truly remarkable giant animals. For example, Arthropods, the giant millipede, one of the largest land invertebrates in Earth's history. Meganeura, the giant dragonfly. The high oxygen levels during the Carboniferous period are believed to have facilitated its large size. Megalograptus, the giant sea scorpion. Megalograptus was a massive eurypterid, an ancient group of aquatic arthropods related to scorpions. And so on. These incredible giant animals of the Carboniferous period provide a window into the diverse and often surreal ecosystems that existed millions of years ago. The Carboniferous period saw the appearance of the first extensive forests on Earth. These giant trees store carbon dioxide and release oxygen in huge quantities. Forests consume as much oxygen as they produce, so they don't contribute any extra oxygen to the atmosphere. It is the ocean that will play the role of regulator of oxygen, byproduct of photosynthesis. The more carbon dioxide photosynthesis consumes, the more oxygen it produces. It is during periods of high photosynthetic activity that the oxygen concentration rate increases. Oxygen is only in the atmosphere. The organic matter is not breathed in and metabolized. Forests develop as coastal plains and swampy areas. The larger insects are the more oxygen they need. These giant insects resigned supreme during the Carboniferous period and were at the top of the predation scale to their larger size. They find food and abundance. The oxygen level is maximal and no predator opposes their development. But then about 305 million years ago, something happened. The climate had been shifting for several million years from steamy and tropical to drier and more seasonal, and that shift took a toll on the swamps and rainforests, which slowly began to disappear. By around 299 million years ago, most of those humid forests were gone. And along with them disappeared a host of early amphibians, like Cochleosaurus, that couldn't cope with the newly dry conditions. This extinction event is sometimes called the Carboniferous rainforest collapse, and set the stage for a takeover that would be a crucial turning point in the history of terrestrial wildlife. Prehistoric fossils help scientists understand what life was like at the time of Pangea about 300 million years ago. At the beginning of the Permian, the last period of the Paleozoic, primitive mammals were already living on lands abundantly covered with forests. It was at this time that reptiles began to emerge and multiply rapidly. It turns out that it is only possible to find these fossil remains for one simple reason. All the continents once formed one land and were not separated by the waters of the oceans, was a reptile that lived on our planet during the Triassic period. When Pangea existed, scientists have discovered the remains of these animals in South America and Africa. The remains of Listrosaurus, another land reptile, have been found in India as well as in Antarctica and Africa. If these lands were not part of a single Pangea, the discovery of prehistoric Listrosaurus remains in places so far apart would simply be impossible. Paleontological evidence clearly indicates the validity of the theory of the existence and division of Pangea. Many species of animals lived on Pangea, and most of them were very different. During the Triassic period, the first archosaurs, including the famous fossil Archaeopteryx, appeared on Earth and eventually became the ancestors of modern reptiles and birds. At the end of the Triassic period, as mentioned earlier, dinosaurs also inhabited our planet. However, these new dinosaurs didn't look quite like the ones in Jurassic Park. Researchers believe that these dinosaurs had very porous bones that were covered in feathers, not scales like the reptiles. We are familiar with most of the living organisms that at that time inhabited the seas. During this period, many classes and types of living beings appeared. At the very beginning, all living organisms lived in the seas. And the most developed of them were fish, many species of corals and trilobites, marine arthropods which lived exclusively in the Paleozoic. Amphibians were less numerous and remained mostly in the water. Most of the species that lived on Earth during the existence of the supercontinent of Pangea became the ancestors of modern animals. More advanced plants appeared during the time of Pangea. Indeed, the diversity of plants of different colors explodes. The Earth's land masses are divided into 7 continents, each with its distinct shape and geographical features. At first glance, this statement seems rather obvious and unimportant. But it turns out to have a profound impact on human behavior or wildlife. The shapes of continents are more than just geographical quirks, they have significantly impacted human behavior, culture, and history. From migration patterns and trade routes to cultural diversity and geopolitical dynamics, continental shapes have played a pivotal role in shaping our world. The shapes of continents are not only aesthetic features of our planet. They have a profound impact on the natural world and the diverse array of species that inhabit it. From creating varied habitats and influencing migration patterns to shaping marine ecosystems and island biodiversity. The contours of land masses play a crucial role in the intricate web of life on Earth, impacting the movement, adaptation, and speciation of animals over millions of years. Understanding how different continental shapes have influenced animals can provide crucial insights into conservation efforts, species management, and the preservation of our planet's rich biological heritage.